Okay, so let's look at some typical results for this experiment. So you can see number of Skittles on the y-axis, time on the x-axis, number of Skittles decreases, but not in a linear fashion. So we draw a best fit line. It's a little bit hard to do in this computer, but try and make it as smooth a curve as you possibly can. Okay, don't worry if your results are slightly scattered around that curve, but nice smooth curve. There's then a few questions to answer in this. So the first one, it says how many Skittles remain in the first 5.5 seconds. Now, hopefully you've started off with more Skittles than me, because this is a little bit tricky, because it's very little at 5.5. But what I would do is, where 5.5 is on your graph, draw a line up, draw a line across from there. Make this a little bit smaller. I'll get my ruler. Something like that. And it's not very accurate, but I'm going to say it's about 1. Okay. How much radiation is released in the first 3 seconds? Well, if we go to our 3 seconds and draw a line up the ways. Now I should really take it off the line, but if I'd drawn that smooth line properly, it would have gone through that point. So I'm just going to go across kind of from there. Okay, so from the curve, even though it doesn't go through that point, and that's at about 9. Okay, so I'm going to say that there are 9 Skittles remaining, but that doesn't answer my question, because my question is how much radiation has been released. Radiation is released when a nucleus goes from being unstable, decays, and becomes stable. So we started off with 80 unstable nuclei. In the first 3 seconds, that has decreased to 9 according to a curve, not according to the actual table of results for this. So therefore, the number of those unstable nuclei that must have decayed and become stable is actually 71. So we would get 71 pieces of radiation emitted in those first 3 seconds. Question 3 then asks, how long does it take for the number of Skittles to half? Now, what we do is, starts off at 80. How long does it take to go down to 40? It's 1 second. Okay, so it takes 1 second, according to our graph, for this to half. How can I make that more reliable? Well, I can do it again. So I can go from 40 down to 20. Okay, so half of 40 is 20. That happens at 2 seconds. It doesn't mean it took 2 seconds from it to get to 40 to 20, because there were 40 left at 1 second. Therefore, it took 1 second again. So our average of those 2 times, this is from 80 down to 40, and this one here was from 40 down to 20, and I could actually go back and do it again from 60 down to 30, or from 20 down to 10, or from 10 down to 5, but 2 results is at least repeated. The average of 1 and 1 is unsurprisingly 1 second, but I would show that in an exam to show that you've taken 2 readings for the time and taken the average to make it more reliable.